All right, this lesson is going to be about absolute value and composite functions. The very first part of that, if we were in class together, I would probably do a little review with you. And so these first few slides, I'm actually just going to scroll through. You can fast forward a little bit if you don't want to do these. These are a little review of lines. But I'm going to scroll through these slides. You can hit pause if you want to. And I will just show you the answers to these in case you want to double check to make sure you know what you're doing. So here we go. All right, and now we are going to start looking at absolute value and composite functions. All right, this equation right here is the basic absolute value function. Y equals the absolute value of x. It is a piecewise function because it doesn't have the same, if you look at this piece, and obviously it is the slope of a line, that has a negative slope. If you look at this piece, it has a positive slope. So clearly those lines would have different equations to them. And so because they have different equations in different parts, they are an example of a piecewise function. Okay? So that is an absolute value function. I want to talk about if it is odd or even, first of all. Okay? And because it can be folded across the y-axis, and when you think about that, remember to check for even or odd, you plug in opposite numbers. So if I plug in 2, I would have the absolute value of 2, which is 2. If I plug in negative 2, I would have the absolute value of negative 2, which is also 2. And also, like I already mentioned, it can be folded across the y-axis. It is symmetric to that. And so plugging in the opposite value gives you the same answer. And when you plug in the opposite value but get the same answer, then you know it is an even function. So absolute value functions, or at least the basic absolute value function in this case, is even. What happens here is this piece right here, it has an equation that looks like this. The slope is 1 because you go up 1, right 1, up 1, right 1, up 1, right 1. So it would be 1x, and then it crosses the y-axis at 0, so you would technically have a plus 0 behind there. But that only happens when your x values are greater than or equal to 0. Okay? Then this part over here is the same kind of thing, except for it has a slope of negative 1 because you're going down 1, right 1, down 1, right 1. But that only happens for x values that are less than or equal to 0. Okay? So you have different equations for different parts of your graph. So an absolute value function is an example of a piecewise function. Okay? Here is this one. Okay, now this is a little, not the basic absolute value function, but it looks like this. I first of all want you to be able to graph it. So one thing you can do to graph this is to put this into your graphing calculator, which I'm going to do, and I'll show you how to do that. Use your graphing calculator to help you, and then you can get the tables too. So I'm going to go to my graphing calculator here. If it pops up, hopefully it will. It did. Okay, and I'm going to go up to y equals here. And you get the absolute value key under the math button. So if you go under math, and then over to number, and then absolute value is number 1. And somehow I must have pressed the wrong button. So let's try that again. Math, over to number 1. There we go. The absolute value of x minus 2, I want to close my absolute value now, and then minus 1. Okay, if you hit graph, this is what it will look like. Okay, so you can do that. And then if you want to go to your tables to help you, you can go to your table and you can actually get some points to plot. So I could plot the point 2, negative 1, 3, 0, 4, 1. And eventually you'll kind of see a pattern in here that things will get smaller and then bigger, and that is kind of a key thing. Right here is sort of a symmetric point in your graph where things start to change. Okay? So that is that, and if we kind of you can use your table to plot those points and go from there. Okay? What I want you to notice is that this minus 1 on the end moved the basic absolute value function down 1. Okay? And this negative 2 that's in here move the absolute value function 2 to the right, opposite of what you would think, but kind of how shifts worked when we did sine and cosine functions as well. Okay, so that 2 that's in the absolute value will move the basic absolute value function 2 to the right. The negative 1 will go 1 down. So it will look something like this. And again, if you don't know how to figure that out, you can use your table and plot these points. You can also make your own table if you want and plug some points in. But it should look something like this. Okay. So I want to talk about its domain and range, okay? And again, once you have a graph, it's pretty easy to figure out domain. But domain, you want to look at, think about drawing a line that looks like this, and then moving it left and right, and thinking about if there's ever a spot where the graph, the pink line and the red line, won't eventually intersect. And you need to remember that those red lines go on forever and ever and ever, and so does the pink line. So even when it's way over here, they'll eventually connect in the upper right-hand corner. Okay, so your domain of this function would be all reals. So I could write it like this. Or I could write it like this. Okay. And then the range of the function is what your y values can be. And to figure out your y values, you want to take your line and go the other direction. So I'm going to draw one this way this time. Okay, and at this time I want you to think, are there spots that your pink line won't hit? And it's not hitting the graph down here, so those are not in the range. Whoops, I just messed that all up, didn't I? It's not hitting your graph right there, so those aren't in the range. But if you move your pink line up, it starts hitting the graph down here at -1, and as I move that pink line up, it's always going to eventually intersect the graph, even way up here, because your lines go on forever and ever. Okay, so your range would be from -1. I need to lock that graph, sorry. Your range would go from -1 up to positive infinity. So your range could look something like this. Or it could look something like this. However you want to do that. But those are the two ways that you would define its range, okay? All right, then we are going to look at composite functions. Composite functions basically are using more than one function machine at a time. So you input something into the first function machine, it spits out an output, then you take that output, put it into the second function machine, or however many you're going to do, usually just 2, and then it will go, it has a rule that it uses 2, and then it gives you an output. Okay, so composite functions are just looking at more than one functions at a time and taking an output of one, putting it into another machine, and figuring out what happens. Okay? So if this is kind of what was happening here, I told you that f of x was x squared and g of x was x plus 3. So if I was sort of following the pictures right here, and I'm using the value of x equals 4, okay? So this is what I want you to do. I want you to put x equals 4, and I want you to put it into this machine. And this machine is f of x. So to figure that out, I would have to go f of 4, and that would be 4 squared in this case, because f of x is x squared, okay? So I would take f of 4, which gives me 4 squared. That gives me 16 as an answer, okay? So right here would be 16. That's my output. Then I'm going to take that, I'm going to put it into the next machine. So now I'm going to put it into G's machine, okay? But in order to put it into G's machine, I have to use G's rules. And G's rules are to take x plus 3. So now I would go G of 16 equals 16 plus 3, okay? And 16 plus 3, if I take that in here, I would get 19. Okay, and that is my final output. So notice what I did. It looks like this, but you always work inside out. So when you're doing this, this means you're going to put the input into F first, get an output, put the output into G. Okay, so you can kind of picture how those function machines go. In the end, you're going to get 19 for your answer. We already talked about that. Okay, you can see it written as G of f of x. That's what that looks like, and that's how you would read it. G of f of x. It also might be written like this, G of f. And sometimes it'll have just this, and sometimes it'll have G of f of x, like that. Whoops, not that second parentheses. But either way, it means the same thing. And we'll do some examples of that so that you can see. All right. Couple things. So right here, again, you work inside out. So this is your first input, and then you put it into this. Okay? So this is telling you to take 1 and plug it in. So the first thing I'm going to do is I'm going to take 1 and plug it into G. So G of 1 is 3 times 1, which is 3. Okay? Then I'm going to take that output and I'm going to put it into F's equation. Okay? So when I put that into F, then I will have F of 3 equals 3 cubed minus 1, which of course is 27 minus 1, which we know is 26. Okay? If we do it the other way around, again, we will work inside out. So this is telling us to take the input and put it into F's machine first. Okay, here's my input that I gave you. My input that I gave you is that X is 1. So when I do 1 here, I put it into F first because it's on the inside. So I will go F of 1 is 1 cubed minus 1, which is 0. Okay, then I'm going to take that output and I'm going to put it into G's equation. So then I have to find G of 1, or G of 0, sorry. My output was 0, would be 3 times 0, which of course is 0. Okay. Sometimes it'll give you just this, and it'll look like this, and it doesn't even give you a number to use, which seems kind of weird. But it doesn't give you a number. This, by the way, is the same as doing F of G of X. Okay? These two things are simultaneous to each other right here. They mean the exact same thing. And that's what you're going to do. Now, sometimes it doesn't give you a number to plug in, and we're going to do that on the next screen. When it doesn't give you a number to plug in, what are you going to do? Okay? So here we go. This one is just simply asking you to find a formula for F of G, and it doesn't say have the X behind it, but again, what this really means is F of G of X. So that little circle kind of replaces the parentheses. Think about that. This is telling you to put G, you're going to put your function of G into F, because you always work inside out. Now, it didn't give me a number to plug into G. It just says plug X into G. Well, guess what? I've already got X plugged into G. So all this is saying is you're going to take G's function with X plugged in. I already have X plugged in. And you're going to input it into F's function over here. Okay, so what this is really asking you to do is F of 2x plus 5 equals 2x plus 5 squared minus 1. And I should kind of do that. Okay. Then you get to simplify this a little bit. Remember that 2x plus 5 squared is not 4x squared plus 25. Super common math mistake, but 2x plus 5 squared really means 2x plus 5 times 2x plus 5. Okay, when you FOIL that out, you're going to get 2x squared plus 10x plus 10x plus 25. Okay, and then when you simplify all that, you'll have 2x squared plus 20x, and then 25 minus 1, of course, is 24. So this is the formula right here for F of G of X. Okay. Kind of another one. We're going to go the opposite way this time. Again, I did not give you a formula to use, but you know that this is the same as G of F of X. Didn't give you an input, so this inside part is saying use F's equation and plug X into it. I already did that. I used F's equation and I plugged X into it. I did that piece, okay? So that piece is the square root of X. That's my output in this case. Then I'm going to take that output and I'm going to put it in to G's equation, okay? So I'm going to take G of the square root of X, and I'm going to get the square root of X squared plus 3. Well, when you square the square root of X, you just get X plus 3. Okay? All right. That should do it for us. And we are going to have a quiz coming up. I will talk to you about that. But there is your homework assignment that you will be coming up with.